welcome back. We're still on simultaneous equation, still using elimination method, but this time is the part 2. In this video, we'll be looking at elimination method, and we'll be seeing simultaneous equation with factorizable large numbers, equation with brackets, and equation with decimal. All this will be solving using the elimination method. I can't wait to see you in class. So we are starting with the first one. I remember in our previous video, I told you that the first thing you need to do in solving simultaneous equation is to label your equation. So we are going to label this to be equation 1, and then label this to be equation 2. Alright, our equation 2 is a very simple equation, but equation 1 looks quite large and bulky, but you can actually solve directly without trying to reduce the equation or make the equation smaller. But it is easier and it will make your work more simpler. What I'm going to do is I'm going to investigate my equation 1 to know if it is actually factorizable. Yes, it is. They have something in common, which is 9. So I'll have my 9 in bracket. 9 factorizing this will be 3d plus f is equal to 63. So up here, I have the step-by-step method of how to do this. First one is factorize the left-hand side, which is what we have done. Then the second one says we should divide the right-hand side with the common factor. So the common factor I have here is 9. So I'm going to divide this with the common factor I have at the left-hand side. So 9 here will give me 1. And 9 at this point will give me 7. So my equation 1 has been reduced to 3d plus f is equal to 7. Now remember, this is my equation 1. I've reduced it. So I'll bring down my equation 2. D plus f is equal to 3. And this is my equation 2. So at this point, I'll solve my simultaneous equation just like I taught you in the previous video. I will eliminate f and f because they have the same coefficient, which is 1 and 1. There's no need of me multiplying anything or doing any other extra thing. Now I will observe the sign positive, positive, so I'm eliminating with a negative sign. So I'll have 3d minus d will give me a 2d. F and f will be 0 automatically. Then 7 minus 3 will give me 4. So I'll divide both sides by the coefficient of the unknown, which is d. And then my d will be equal to. So the next thing I'm going to do is substitute this either in equation 1 or equation 2. So to me, equation 2 will be more simpler. So I'll have 2 plus f is equal to 3. So f will be equal to 3 minus 2. And this will leave my f to be equal to 1. So therefore, my answer will be equal d equal to and f equal 1. So let's try even larger numbers. So for this, I'm going to label this my equation 1. And then I'll label this my equation 2. But these numbers are pretty large. Even if I decide to solve with elimination method or any other method, before I would multiply equation 2 by 10 and equation 1 by 27, I'll have very large numbers I'll be working with. One, this might even confuse me, make my work bulky, and most of the times not even organized. So what am I going to do? I'm going to investigate equation 1 and also investigate equation 2 to know if they have a common factor, and this will leave me to factorize and make my equation smaller. So from equation 1, it has a common factor 5, and that will give me x. That will give me 5x minus 2y is equal to 95. So I'll divide here by 5 and here will give me 19. So my equation 1 has been reduced to 5x minus 2y is equal 19. So this is my new equation 1. So I'm going to factorize 9, which will give me 4x minus 3y is equal to 162. So this will give me 1, and here will give me 18. So my new equation 2 will be 4x minus 3y is equal 18. This is my new equation 2. So you found out that the equations are smaller and will be easier to solve with. Okay, so I'm bringing this down here, and I have 5x minus 2y is equal 19, and 4x minus 3y is equal 18. So I want to eliminate y. I'm going to multiply here by 3 and multiply here by 2. This will give me, I'll come over here and I'll have 15x minus 6y is equal 57. I'm multiplying this, I will have 8x minus 6y is equal 36. So the y I want to eliminate has negative sign. So I'm eliminating with a negative sign. So 15x minus 8x will give me the 7x. This one automatically eliminated is equals to 57 minus 36 will give me 21. So I'll divide both sides by 7, and then my x will be equal 3. So I'm going to substitute the value of 3 either in equation 1 or equation 2, and I prefer equation 1. So this will be 5 multiplied by 3 minus 2y is equal 19, which will give me 15 minus 2y is equal 19. Collecting like terms, I'll have negative 2y is equal to 19 minus 15, and negative 2y will give me a 4. So dividing both sides by negative 2, my y will be equal to negative 2. So that will leave my answer to be x equal 3 and y equal negative 2. Alright, so let's move to the next equation we have to solve in this video, which is solving simultaneous equation with bracket. And in this simultaneous equation, 1, it has a bracket, 2, it is not properly arranged. In my previous video, you can check that out, where I taught you how to solve simultaneous equations that are not arranged properly. So for the sake of this question, I'm going to label. You can decide to label first or not. Then I'm then going to open my bracket. So I'm solving equation 1. Let me solve equation 1 first. So I'm going to open the bracket, which is 7x plus y is equal y minus x. So this will give me 7x plus 7y is equal to y minus x. And the next thing I'm going to do from the instruction we have here is to collect like terms. So this will be 7x plus x plus 7y minus y will be equal 0. And this will give me 8x plus 6y is equal to 0. Now this is my new equation 1. I'll do the same again for equation 2. I will have 3x plus 3y is equal y minus 8. So opening the bracket, I will have 12x plus 12y will be equal y minus 8. So collecting like terms, this will be 12x plus 12y minus y is equal a negative 8. This will leave me to 12x plus 11y is equal a negative 8. So this is my new equation 2. Alright, someone might say, okay, equation 2 looks big and bulky. No, please. Because if you investigate, they don't have any common factor. There's no common factor between 12 and 11. So no, we are not using the previous one I just did here with on equation 2. So then I'm going to solve my equation 1 and equation 2. So I'll have 8x plus 6y is equal to 0. Then 12x plus 11y is equal to a negative 8. So what am I going to do? I want to eliminate y. So I'm going to multiply here by 11 and multiply here by 6. This will be 8x plus 66y is equal to 0. And this will give me 72x plus 66y equal I want to eliminate has positive sign. So that means I'm eliminating with a negative sign. I'll have 8 minus 72 will give me 16x. This one is automatically gone. Then 0 minus 48. I'm going to solve this here for clarity. 0 minus this negative sign, then negative 48. Negative will be positive, so that will be 0 plus 48, which will be equal to 48. So this will be equal 48. So I'll be dividing both sides by a 16, and that will leave x to be equal 3. So I'm going to substitute the value of x either in equation 1 or in equation 2. So I prefer equation 1. So this will be 8 multiplied by 3 plus 6y is equal to 0. So this will give me 24 plus 6y is equal to 0. Collecting like terms, I will have 6y is equal 0 minus 24, which will give me negative 24. So 6y is equal to negative 24, and this will leave y to be equal negative 4. That is when you divide both sides by the coefficient of the unknown, which is 6. So that will leave our answer to be x equal 3 and y equal negative 4. Let's try this one out too. This is also equation with bracket. So at this point, you can pause the video, try this one out, and know if you actually get the answer. Then know if your answer is actually correct. So for this one, we are going to label this equation 1. We're going to label this to be equation 1 and this to be equation 2. So let me solve equation 1 first. So what am I going to do? I'll open my bracket. So I'll have 3 times 2x will give me 6x minus 3 times y will give me 3y is equal x plus y plus 5. Now the next thing I'm going to do is to collect like terms. So I have 6x minus x minus 3y minus y is equal 5. And this will be 5x minus 4y is equal 5. And this will be my new equation 1. So let me also solve equation 2. 3 times 5 or 5 times 3 is 15x minus 5 times 2 is 10y is equal to 2 times x is 2x, 2 times y is 2y plus 1. Now what will I do next? I'm going to collect like terms. So I'll have 15x minus 2x minus 10y plus 2y is equal 1. 15x minus 2x will leave me with 13x minus 8y will be equal 1. Okay, so this will be my new equation 2. So what am I going to do next? I am going to solve. I'll come over here and I have 5x minus 4y is equal 5. Then 13x minus 8y is equal 1. I want to eliminate y, so I'll multiply here by 8. Then I'll multiply here by 4. So this will leave me with 40x minus 32y is equal 40. And this will leave me with 52x minus 32y is equal 4. So because the number I want to eliminate has a negative sign, I'm going to eliminate with negative. So I have 40 minus 52 will give me a negative 12x. Then this one automatically eliminated. 40 minus 4 will give me 36. So I'm going to divide both sides by the coefficient of the unknown, which is negative 12. And that will leave my x to be negative 3. So I'm going to substitute this either to equation 1 or equation 2. So I prefer equation 1. So I'll have 5 in bracket negative 3 minus 4y is equal 5. This will give me negative 15 minus 4y is equal 5. And this will, collecting like terms, this will be negative 4y is equal to 5 plus 15. Negative 4y will be equal to 20. So dividing both sides by the coefficient, this will have my y to be negative 5. So this will leave my answer to be x equal negative 3 and y equal negative 5. At this point, you might decide to take a break before we continue. Alright, we are moving to the next equation, which is equation with this by eliminating a or b, multiplying by the different coefficient. But I'm going to show you how to solve this very easily. The first thing you need to do is you should convert the decimal to whole number by multiplying with either a 10, 100, or 1000. So how am I going to do this? I am going to investigate. The first thing I'm going to do is to investigate this equation 1 and equation 2. What common tens should I multiply with? Should I multiply with 10, 100, or 1000 to convert everything here to a whole number? So I'm going to multiply with a 10 because multiplying with a 10 will convert everything here to a whole number. So I'm going to multiply this, everything here by 10, and then everything here by 10. So multiplying this by 10 will give me 15a, then minus 7b is equal 1. And everything here will be 3a plus 11b is equal 25. So multiplying this equation by a 10 has made it a whole number. So I can now continue solving. So remember, this is my equation 1 and this is my equation 2. I want to eliminate b, so I'll multiply here by 11 and multiply here by 7. So this will give me 165a minus 77b is equal 11. And this one will give me 21a plus 77b, which is equal 175. So because b has negative positive, I'll be eliminating with a positive sign. So 165a plus 21a will give me 186a. This one is already eliminated. is equal to 11 plus 176 will also give me 186. Dividing both sides by the coefficient of the unknown, that is 186, my A will be equal to 1. So this will be 15 multiplied by 1 minus 7B is equal to 1. So this will leave me with 15 minus 7B is equal 1. Collecting like terms, I will have negative 7B is equal to 1 minus 15. Negative 7B will give me a negative 14. I'll divide both sides by the coefficient of B, which is 7, and that will leave my B to be equal to 2. So therefore, my answer is A equal 1 and B equal 2. Alright, let's try something else. If we have those numbers here, they're in decimal, right? So we have to try and convert them to whole numbers, either by multiplying with 10, 100, or 1,000. So let me investigate 10. If I multiply this by 10, no, it won't give me a whole number. No, this will give me a whole number. This will give me a whole number. But these two will not give me a whole number. So no, I'm not picking that. Alright, so let's also investigate 100. 100 will change everything I have here into a whole number. So that means I'm going to multiply everything here by 100 and everything here. So this will leave me with 232m plus 144n is equal to 1560. This is my equation 1. And this will leave me with 480m minus 192n is equal to 288. And this is my equation 2. But there's something still wrong with this equation. It is very large. I can work with this number, but it will make my work more difficult, bulky, and might even confuse me along the line. So what will I do? Previously, in this same video, we have done factorizing equations that are factorizable in simultaneous equations to reduce them into smaller numbers. So for equation 1, I investigated and they have common factor 8. So 8 at this point will give me 8 factorizing is 29m plus 18n will give me equal 1560. So when I divide, this will give me 195. So my equation 1 will now be 29m plus 18n is equal 195. And this is my new equation 1. I'll also do the same for equation 2. What they have in common is 96. 96 here will reduce 480 to 5m minus 192 will be 2n is equal to 288. So when this divide here will be, I will have 29m plus 18n is equal 195 and 5m minus 2n is equal to 3. So I want to eliminate n. Multiply here by 2 and multiply here by 18. So 2 here will give me 58m plus 36n equal 390, and 18 multiplying here will give me 90m minus 36n is equal 54. So I want to eliminate n and it has positive, negative. So I'm eliminating with a positive sign. So 58m plus 90m will give me 148 and give me 444. So I'll divide both sides by the coefficient of m, which is 148, and my m will be equal to 3. So I'll substitute the value of m either in equation 1 or equation 2. So at this point, I prefer equation 2 because it is quite easier. So this will be 5 times 3 minus 2n is equal to 3. This will leave me with 15 minus 2n is equal to 3. Collecting like terms, I'll have negative 2n is equal to 3 minus 15. And this will be negative 2n is equal to negative 12. Dividing both sides by the coefficient of n, which is negative 2, my n will be equal to 6. So that will leave my answer to be m equal 3 and n equal 6. So at this point, we are done with the video. I hope you enjoyed it and I hope it was impactful. Alright, so we're having another part in elimination method, that is part 3, where we'll be looking at simultaneous equation with pattern, quadratic simultaneous equation, and other interesting simultaneous equation. Then we'll now be looking at solving using substitution method. Don't forget to like, subscribe, and hit the notification button to get notified when interesting math video like this is being uploaded in our page. So thank you and see you next time.